All right, so my name's Helen, and it is my pleasure to introduce you today to our next speaker, Egor Ushakov. He's going to be speaking to us today about the debugger in IntelliJ IDEA and how it's a hidden gem. So, Egor, welcome. Really excited to have you here today. Are you looking forward to your talk?
Hi, Helen. Thanks for having me. Yeah, I'm really excited to tell you more about the debugger features. So as long as we have so many people interested in that. And I hope there's actually more. So I see the stream currently, we have 124 likes. So if there are more people interested in debugger features, please add some likes there. I will see that, and that will provide a lot of support for me. Thank you.
Fantastic. One-man mission to upvote for the debugger. So Egor is exceptionally passionate about performance analysis, and he leads the development of the debugging, profiling, and coverage tools in IntelliJ IDEA. So he's going to show us some of the developer processes that we can use for the debugger so we can be more productive with a range of techniques. Fun facts, the debugger was first introduced into IntelliJ IDEA back in 2002, for any of you that remember that far back. Of course, it's been evolving ever since, so it's going to be very interesting and insightful to hear about what makes it so valuable for us developers today. Housekeeping tasks, please do continue to add all your questions to YouTube. I will be putting them to Egor at the end of his presentation, time allowing. And fun fact about Egor is he never has to think about how long he's actually been with JetBrains because his daughter was born a week after he joined the business.
Yeah, her name is Alice, and she's 7 now.
Fantastic. Right, I will add your screen, Egor, and then I will hand over to you to do a well-anticipated or greatly anticipated presentation. Over to you, Egor. Thank you.
Okay, thank you, Helen. So hello everyone, and currently I look at the stream and we have 188 likes, so at least how many? 50, 60 people are interested in the debugger. Okay, so today I'm going to tell you a lot about debugger features in the IntelliJ IDEA, and probably some of them are somewhat hidden, and some of them are not applicable to kind of non-Java world, but you will see that many of them could be kind of used in other languages and technologies. Okay, so let's go. So first of all, why do we debug at all? So as someone said already, they don't have bugs, so they don't need debugger. So many people use the debugger only to find bugs and to fix bugs. And that's perfectly fine. Well, the debugger was originally created for this purpose. But in the modern world, if you think about the debugger as a kind of window to the runtime information of your application, you can get much more from that. So for example, you can analyze the code. So I usually do this. So when I see a huge amount of unknown code, I set a breakpoint there, and then using the runtime information, I can understand it much better and much quicker. So then you can, of course, see which parts of your of the code are executed and which are not. Also, some people tend to replace debugging with logging and kind of system out, println in Java and so on, because it is faster. Well, in some cases it is faster, but using the debugger, you can do the same and much more. So I will show you today some techniques how to use logging together with the debugging. Also, with the debugger, you can change the behavior of your application on the fly. So otherwise, you have to change the code, recompile, restart your application, and then see how it changed. But in the debugger, you can change how it works right on the fly without the need to restart and so on. And I will show it today for you as well. Also, right in the debugger, you can do memory analysis. So maybe it's not that kind of deep and good as in a standalone or in the built-in IntelliJ IDEA memory analysis tools, but still you can do some simple memory analysis, and I will cover that today as well. So always debug. I kind of, in Java world, I don't use run action for my Java applications. I always use debug, just because at any point you can set a breakpoint, stop the application, and see what's happening inside. And it is much more useful than just printing stack trace here and there, because you can see variable values and all the rest runtime information from your application. Okay, so what changed in the year 2014? Everybody knows that Java 8 came out in this year, and it introduced lambdas, and everybody started using them, and everybody likes to write one-liners like this. So you can have streams, and also streams were introduced in Java 8. So now you can write a stream processing in one line using three lambdas. Okay, this one is kind of trivial, but anyway, you can use it in one line. And Java debugger historically operates with line numbers. So both these three both kind of lambdas and the original line are located on the same line in the code. So it's it was really tricky to debug such code when Java 8 came out. So we introduced probably a year later, maybe half a year later, we introduced lambda breakpoints. So today you can set a breakpoint in a specific lambda on the same line. So for example, you can set a breakpoint inside this first lambda, and then you can debug this code and immediately stop right here in the lambda. So, and this breakpoint will work only in this lambda. So you can set a condition, for example, for I value here. So if you stop on a breakpoint in every lambda on the line, you will have different variables like X here and K here. So adding a condition for this would be kind of impossible. So you will get a lot of errors for this condition if you have it like this. So in IntelliJ, you can do stuff like this. But also, you can do run to cursor. So for example, if we set our cursor here in this lambda, and we, I will just show you the tool winner, and we do run to cursor to here. So we will immediately stop in this lambda. So for this kind of simple transitions, you don't have to use the breakpoints at all. And then you can do run to cursor again here to stop in the next invocation of this lambda. And this is really easy, but more of that, if you stop kind of at the beginning of such expression and we restart the debugger here, and from here you want to get into, for example, kind of this lambda directly, you can do step into. And as you know, debugger in IntelliJ IDEA shows you the kind of variants where you can step into and you can navigate using your keyboard or the mouse. And of course, filter and peek and toArray are not that interesting for us here, but lambda is interesting. So we can select the lambda, hit enter, and appear directly in the lambda. So this way, it's really easy to navigate through lambdas in your code, even if they are on the same line. So to implement this was somewhat tricky because Java generates code for lambdas, and the class names and the method names are not kind of specified. So we had to match those names with the code. And in that, of course, we used the IntelliJ IDEA analysis, different analysis to do the matching between runtime information and the code information. And now we can do this kind of without any problem. So you can use lambdas in the IntelliJ IDEA debugger as kind of first-class citizen. The same way you put breakpoints on lines in the code before. But why would you want to debug streams with all this kind of fancy lambda debugging if you have stream debugger? And in IntelliJ, we have another kind of really, really exciting way to debug your streams. So if you have a terminal operation for the stream in the expression and you stop on a line like that in the debugger, it activates the action, this action here, like trace current stream chain. And if you click on that, oops, it's on another screen here. And if you click on that, it will evaluate the stream and you will see how the data is kind of transformed during the stream stages. So here, the initial data consisted of six numbers. And if you click here, you will see that that flat map transformed it into these 11 numbers here. And you can click on the exact item here and see So where exactly it was transformed. And also, if you click on next stages, you will see that distinct remove duplicates, and you will see which kind of duplicates were actually removed. Sorted, of course, sort them, and this is understandable. And toArray just put them into the resulting array. Also, we have a flat mode here. So if you click on this, you will have the general picture. And sometimes it's really cool to see how your data was transformed. And of course, this presentation will be available for objects, not only for primitives. Of course, for objects, you have to have kind of a good toString to be able to quickly observe what objects are inside, but they will be expandable here. So you will still be able to find out what's kind of how your stream is being processed inside. So from here, you may probably be able to quickly understand what kind of stage is malfunctioning, and then continue debugging this a particular stage step by step. Like, for example, here we may be interested in factorize, and then we can set a breakpoint inside it and step by step debug if there's a problem there. Okay, so even before lambdas, there were some cases when you needed a breakpoint on a method inside the interface. So kind of you don't care about the exact implementation of that interface. So there may be kind of huge amount of them, for example, 100, maybe 1,000. But you care about the first invocation of a method. So historically, well, method breakpoints, they had it as kind of maybe since the beginning in Java Debugger, but they were really, really slow, and they are slow actually. So we asked users not to use them, and we even showed a notification if user created a method breakpoints that method breakpoints will slow down or may slow down your application significantly. And they really kind of do that because once you have a method breakpoint in the Java debugger, not the IntelliJ IDEA debugger. So if you have a method breakpoint, all your applications starting to be interpreted in the JVM. So this is kind of really, really slow. So, but otherwise, method breakpoints are really useful. So we decided to do the emulated method breakpoints. So currently, all method breakpoints are in the IntelliJ IDEA are emulated. What it means, we find all the implementations of this method from the interface, and we set a line breakpoint in the beginning of this method, and also at the return kind of instructions, if you really care about the method exit, so like here. This way, it works really, really fast. So the only kind of slow thing here is to find all the implementations. So if you have a lot of classes, it may take some time, but still after that, it will work really, really fast because line breakpoints are really fast. So let's say we have bool method here, and we have it implemented in kind of 2 classes somewhere, and it is really called somewhere just because we don't care. So we set a method breakpoint here, and we start the debugger. And from here, you can quickly see that really this method bool was kind of invoked from here, and we stopped in class 2. Okay, but this actually is not interesting because we can do find usages of bool and immediately stop here. So like this is the only usage. So we can set a line breakpoint here, do step into. So what's the point of method breakpoints in this case? So I will show you another example. So for example, foo here. So we can see it is implemented somewhere. But if we do find usages, it says there are no usages because kind of we don't have the invocation of this method anywhere. So let's put a method breakpoint here and start the debugger. So we immediately stopped somewhere in class 3. Because this method, and from the frames view, we can quickly see because it is invoked through reflection. And reflection invocations are really, really hard to track using static analysis because this kind of method name could be generated, maybe composed from several strings or whatever. So it's really hard to track that using the static analysis. And here it works like automatically from the box. And once again, if you have a lot of objects implementing this interface, you will stop in the first invocation of this method in any implementation available. So I tend to use this a lot in IntelliJ IDEA because we have a common class, probably abstract class, and action, which is the base class for all actions in the IDEA. And I don't remember, and usually it's hard for me to find the exact class of some particular action in the IDE. So I set a breakpoint on the very, very base method of an action, like action performed. And then I just do the action in the IDEA, and I immediately stop in the exact action, which does this action, it does this user action. So method breakpoints, you can use it, and you can use it maybe, I don't know, since 2017. So we removed this notification and we ask users to use it more, because this way you can kind of be really, really more productive debugging things. Okay, so for breakpoints, we have a lot of settings actually. And if you open the breakpoints window, it will show you a lot of them here. So there are many filters here. So I will not cover condition. It's really kind of simple and trivial, and a lot of people know them. And we have more of that actually. And I will not tell you actually today about any of this. I want to show you another way how to use them in a more simpler and effective way. So for example, consider this kind of piece of code. We have work method, and it does something. So it really does something. Okay. And it does something in two different kind of scenarios, like a warm-up scenario and real work scenario. So it's just simple loops. And probably you care about debugging this method only when it is in this real work kind of scenario of your application. But here we can see that the first 10 invocations will be from the warm-up method. So how do you say the debugger don't stop when work is called from the warm-up method? And there is actually a filter for this here. So it is called caller filter. And you can go there and set it up manually, but I don't advise you to do that. Instead, when you stop on a breakpoint, use Alt-Enter to call the intentions. And here it will kind of tell you what it can do with this breakpoint using the information it has right now. So for example, you can set it to stop only in the current class, or don't stop in the class. Or you can tell it to stop only in the current object if you care. Or you can tell it stop only if this method, currently work method, is called from the warm-up method. And with this one, we don't kind of interested in. So we tell it don't stop if called from warm-up. And it will automatically populate the caller filter with this kind of full descriptor of the method. And when you resume your session, you will immediately stop in the real work kind of invocation of the work. So if you restart it, it will be preserved, of course, and you will stop only in the part of the application you are really interested in. So this way, it's really, really easy to set up the filters for the breakpoints. And I kind of advise you not to go there in the dialog and set them by hand. No, don't do that. Use intentions. It's really easy, simple. You stop somewhere you don't want to stop, just use Alt-Enter and filter this place out. Or kind of you stop somewhere you only want to stop in this context, just add some filters from there. And from that time, just stop where you want to stop. Okay. So finally, kind of, we stopped somewhere. So we set our breakpoints. We can use method breakpoints, lambda breakpoints, other types of filtering, and so on. So we stopped in our application. How do we check where we are? So of course, everybody knows the debugger tool window, but we have some kind of easier ways to check, for example, variable values. And the first one is the Inline Debugger. So I passed some parameters here. They are really, really simple, but you can quickly check their values right here in the editor. So Inline Debugger puts a note with the variable values after the end of the line where the variable is referenced or declared. So args is an object here, so you can click and expect the kind of the inner structure of this object. And this is kind of the regular debugger tree. You can change value, create a render, whatever you want with this. For primitives, of course, a kind of expansion is not that interesting, but still this way, kind of getting the values of the variables, you can get them in the most easy way using the inline debugger. Also, if you don't like inline debugger or you don't see the value, you can use tooltips. So if you like mouse, you can just hover the value and get the kind of the runtime value. Also, you don't need to hover a variable. You can hover a simple expression containing variable, and it will provide you with the value. But this way you won't get the values for method invocations because we kind of tend not to invoke methods. But you can invoke method using quick evaluate. So if you're a keyboard guy, not like me, use the quick evaluate action, and I don't remember what it is because I'm a mouse guy. So Control Alt F8 on Windows. And you can select, actually, many people pre-select something and then use the quick evaluate action, but actually you don't have to. So you just put your caret somewhere and use the quick evaluate action, and it will automatically select the minimal expression containing the caret and evaluate it. So you can evaluate here and get the result. You can evaluate here and also get the result. But as I said, I'm a mouse person, so I like to be quick and do like a headshot with the mouse. So I use AltClick Evaluate. So what it is, so if you hold the Alt button on your keyboard, and on other platforms, maybe not Alt, I don't remember exactly. On Windows, it's definitely Alt. And you hover your mouse over your code, you will see highlighted what it will evaluate when you click. So for example, if I hover here, I click and see kind of true. If I hover here and click, I see true again. If I hover click here, I see true. So always true. And this way, it's much faster than tooltips because tooltips have delay. And much better, I would say, than tooltips because before evaluation, you see what will be evaluated. So when you hover, you don't see before it is already evaluated. So I like AltClick. If you like mouse, use AltClick. I think it's the best way to get values of the expressions which you already have in the code. But what if you want to evaluate something which is not in the code? So for example, I may be interested in evaluating args.length, for example. So this is a trivial example, but anyway. So you cannot click anywhere here and evaluate args.length. So for this, you need to use evaluate expression action. So Alt F8, I remember that actually, but I wanted to show you that there is a button on the toolbar. So you evaluate, you start it and you open the evaluate dialog. And from here, you have a one-liner where you can add anything you want to the values you have in the program and get the result. And you can also do so many kind of nice things here. So it's a real kind of editor with completion and so on, but with the runtime information you can get from the program which you are currently stopped at. So this way you cannot not only kind of get values of what you have in the program, but also you can do prototyping and check how to use a unknown for you API. So for example, here I wanted to print the operation system name. And I remember that it is somewhere in system properties of the JVM, but I don't remember exactly which one. So of course I could Google that, but sometimes a kind of debugger is a better Google for your program because it knows more about the kind of real environment it is running on. So what I can do is I can do system get properties and get the list of all properties and then quickly do the search here. And yes, I have the name here. So I can just put it here, check that it returns the correct value, and then copy paste it into the code. Just like this. And then I restart it and quickly, using my favorite alt-click, quickly check, oops, presentation not, quickly check the result is correct. and then quickly check it in the console. So yes, I've done it right with the use with the help of the debugger. But there is a great feature here which is somewhat hidden, and this is this small expand button, and it will transform the one-liner evaluator to the full features code fragment mode. So here you can write any piece of code, well, literally kind of any piece of code, using the variable values you have in your real application. So I don't want to spend time here, but I will just show you some examples. So you can do kind of stream processing using switches, kind of lambdas, mapping, variables available in this context. You can create new runnables, whatever, and see that the result kind of is really printed here. So you can do so many kind of different things, and this is kind of the trivial one, but still it works. So you can use loops, ifs, whatever you could use in a real application. So then you try this piece of code with the real data you have in your program. You just copy paste it, and there you go. You fixed the bug or changed your application, and you already checked that it works. Okay. Non-suspending breakpoints. Sometimes you want your breakpoint not to suspend anything. And why is that? And this is what I've been talking about before about logging. So consider this example. This is a simple cache. So it has a get instance, which returns a cached instance of the cache. And every time kind of, it is lazy initialized. So the first time it is called, it is initialized, and then it returns kind of the same instance every time. So if you start this program, you will see that the output consists of 10 times the same object. So get instance receives a parameter. So for example, if we want to dump a parameter name, we can create a non-suspending, and then click the suspend checkbox here, non-suspending breakpoint that will evaluate and log the value of I. So I set a breakpoint like this. It is kind of yellow because it is a non-suspending breakpoint. And when I start the debugging, I will see in the console the output of this logging. And you can kind of, well, numbers are not that nice. So let's add some nice prefix here. Okay. Yeah, it's much better now. And if you want to disable this logging, you just disable this breakpoint and the logging is gone. And then you can enable it again. And you can do this on the fly. So I restarted this application just because it's simple application, but you can enable and disable it right when your program runs in the debugger. And of course, in this case, we may be interested not in kind of logging all the invocations of get instance, but we may be interested in logging the exact place where the get instance was initialized. So we want this logging breakpoint to be on the next line. So we can just drag and drop it here. And this way, you don't need to recreate everything you kind of set up here. And you can just use drag and drop to quickly move breakpoints if they are on the wrong lines. So this way, you can start it here and see that now it is locked only once. But, well, it's kind of interesting thing. You can not only drag and drop, but you can drag and drop with a modifier, for example, control here. And this way, it will copy every setup of the breakpoint you have. It will copy it to another line. If for some reason you need a special logging on several lines, you can just copy those breakpoints quickly and have them where you need them. Okay, so also there is another kind of nice shortcut for this. If you have a value or an expression which you want to be logged in a certain place in the code, you can just select it and do the shift click on the gutter. And it will automatically do everything I did before for you, and then you will just have this kind of breakpoint, logging breakpoint automatically. So if you use this a lot, kind of use shift click, this will save you some time. And also a really nice and extremely powerful technique to use the non-suspending breakpoints is to change how your program behaves. So for example, we care about the initialization of the cache. And we set a breakpoint here. Unfortunately, if you missed this place already, so for example, if you are already in this loop, you will not be able to get into the initialization of the cache because it is already initialized. So how do you debug this code again? There is a way. You can stop in the get instance and set this instance value to null. So in the debugger, you can change the values. Okay, set it to null. Now you can go here and debug it. This is really easy, but actually there is a even better way. So you can do the same, but in a non-suspending breakpoint. So for example, you set a breakpoint and you say that you want it to set instance to null. Well, it is evaluate and log. So it will first evaluate and then log the result. And the result of the evaluation is actually the fact that the instance will be reset to null. And this will effectively disable the caching mechanism here. So if we see the output of the program, you see that from here on, the get instance result is always new. And if you want this behavior to kind of be disabled again or be enabled again, you just disable this breakpoint. You start the application, okay, now it works as before. And now, for example, if you want to kind of debug it or see how your application works with get instance not being cached, you just enable this breakpoint and voila, you changed how your program behaves without changing the code, without doing nothing to the kind of application itself. You can even do that on the fly. Once again, you can just disable, enable the breakpoint, and the behavior of your application will change on the fly. This is really, really powerful technique. I use it a lot, actually. And also, I have another kind of way of using this. So sometimes you have special flags in your application which are initialized using properties, for example. So if you pass a property, you can have your application working in a kind of debug or whatever other mode. You can do the same using this technique. So you just set a special kind of breakpoint somewhere in the initialization stage of your application, and you set this variable kind of, usually it's a static variable, kind of globally available, and you set it to the value you need. And so when you have this non-suspending breakpoint enabled, you will have your application working in that mode. So no need to add anything to the startup options. Okay, let's continue. Advanced stepping, and this is kind of really cool part. I also like it a lot. So this is a really, really simple application just for the sake of the demo. So it does filter numbers and then it somehow process those numbers. Don't read the code, it does really nothing. So we stop here, we enter the process method. It does something with the kind of the arc, and then it does a print line. So everybody knows drop frame. So if you kind of miss the place in the method where kind of something interesting happened and you want to kind of restart the method from the beginning, you can use the drop frame. And drop frame kind of drop this current invocation of the method, and then you can step into again and do the same method from the beginning. Of course, it has some kind of side effects because it does not restore the global state if it was changed or modified. But still, in many, many cases, it is really, really useful technique. But this is somewhat kind of everybody knows. We have more for you. So let's say I don't want to execute this method further. I want to return it right away, right at this moment here. So Java Debugger can do this. So you can do force return from the context menu of the frames view, and it will immediately return. So this method is a void method. So of course, you don't have to specify anything here. But for example, in here, we may want it to return false, because currently it will return true. So I can tell it to return, and it will ask me, what do you want me to return? And I will tell it false. And now you see we haven't entered the process method. And this way, you can really change how your program behaves kind of totally. So if you don't want a method to be executed, you can just enter it and then do the force return and drop all the calculations and return right away. Also, if you care about exceptions, so for example, here in the process, we may be interested in how the application would behave if an exception happens somewhere. So how do we check this? This program does not throw any exceptions. So there is a way here, and it is called, well, throw exception. And you specify the kind of the object which should be thrown here. And you click on OK, and you immediately stop in the catch block that will kind of catch this exception. And you can see that this is our kind of, oh my God, exception that we created just before. So this way, it's really kind of easy to check how your program behaves, or to somewhat, again, modify the behavior of your application. Okay. Sometimes in the debugging process, you are really interested in some specific objects. So for example, I have two objects here, M1 and M2, and later I kind of may be in a situation where I need to check if this is kind of M1, which I had before, or M2, which I had before. And of course, you can remember these numbers here. These are the unique numbers of the object, but it's kind of not really convenient. Instead, you can use mark object and add a label here, and also you can add a color. So a lot of colors for the debugger. So let's add M1 here and M2 here, and M2 will be green because, well, because. So later, when you enter the process, you will see that this object is the same object we had here in M2. And also, if you go further somewhere, kind of in, for example, this toString implementation, you will also see this label here in the frames view. And it means that the toString is called for the object marked as M2. And this is really, really useful to check if the object is the same as you had before. And also, for example, if you want to compare this M2 with M1 in this context, where to get the M1 object. And there is a way which is somewhat hidden again. In any place where you can do debugger evaluation, you can evaluate special kind of names, like label underscore debug label will be evaluated to the value of the mark object. And it will be evaluated in any context. So because debugger doesn't care about context. So you can evaluate it in everywhere. So for example, I added a watch like this, and I can switch to a very different thread. And this is kind of the Java internal thread. And of course, from here, you cannot anyhow access your kind of M1 object. But using this marked object, you can. So you can even use it as a parameter anywhere here in the evaluation, in the breakpoint conditions, anywhere. Okay. And this is really good, but there's more actually. So let's consider this kind of extended example of this. So we have 3 memory objects, and let's say you forgot to mark them. So here you have only one of them. Let's remove this one. Here you have only one of these kind of memory typed objects, and you want to see other objects of this type. And let's say you don't have them here. They are somewhere in the past. So you know that they are in the heap, but you don't have access to them at the moment. Well, actually you have, because you are in the debugger. It knows everything about your program. So you can right-click and invoke show kind of type object, and it will tell you the current runtime type of your variable. And it will show you all the object it has in the heap, in the Java heap of this type. And from here, you can kind of check what you want from these objects. You can once again mark them, and then later kind of use what you want with this in the debugger. And you can use the full-featured memory view here. So you have a list of classes with the number of instances that are currently in the memory. So you can type here our memory class name, and you can see that we have 3 objects as I've shown you before. But what's more interesting here is that you can actually check every object in the Java heap. So for example, we can see how many strings we have, and we have more than 3,000 strings, and you can expect what's inside, and you can filter. For example, I care only about lines with length more than 1,000 characters. And it will quickly filter this and show you the kind of long lines in your Java heap. And from here, you can also call show referring objects to do simple kind of memory analysis. And it will show you where this line is referred from. It's inside the VM. And also, you can do the same in the regular variables tree, but for this kind of, it's not really interesting because it's local variable. But let's find something, for example, integer objects. We have a lot of them, and they look really, really kind of strange. Why do we have so many kind of similar integer objects? Let's have a look at the referring objects. If you didn't know, integer has a cache inside for small numbers. So if you kind of create a lot of small numbers, it will use cached values instead of creating new values. So this way you can really do simple memory analysis from here in the debugger without the need to take the snapshot of your application memory. And this is much faster, and probably for simple questions like who is holding my object, why is it not being garbage collected, you can use the debugger and avoid kind of using more complicated tools. Watches. So I've shown you before that you can use watches with marked objects, and this way they will stay kind of stay available in any context. With the regular watches, sometimes it's not really convenient to use them because they really quickly goes out of the context and become red, and you don't have kind of anything valuable from them in other contexts. So for example, here we may watches, we have an object which contains milliseconds inside. And if we care about something about a human representation of this, we can add a special class level watch. So we care about this information only in the context of the this object type. So we can add a new class level watch for it, and we can specify an expression here. And in every object of this class watches, it will add this new node in the beginning that will be evaluated and show you the information you require. So this is really useful. Think about it as a special kind of custom fields which you can use to your objects, and they will show you some information about your object only in the context of this object types. But you can actually go to kind of the limit with this. So for example, A is a string value, but you can still add a new class level watch here. So for example, starts with A, and of course it is true. But now in every string object, you will have this node. So let's get back to the memory view, and you will see that in every string object, you have this kind of watch inside. So do we have any kind of object starting with A? And yes, we have, and here it is true. So this is somewhat extreme example, but anyway, I think you get it. And also there is a way to kind of tie a watch to the place in the code. So for example, here we may want to step into the printline method, and this is a library call, well, not library, it's a JDK call. So we may be interested in string s length here, for example. So if we add it here, it will be shown, yes, of course. But when we go out of this context, this watch will be just garbage. We care about it only in the context of this particular method here. So we can right-click here and add inline watch with the same expression. And this watch will be here on this line. So when you enter this method, it will be evaluated and shown you in the inline debugger, right where you need this. So you can stop and restart it, and you will see that this watch is useless. But if you step into the print line method, the value is here and evaluated. And you will also add, you will also have all inline watches here in a special node, just to be able to delete them all at once or navigate to where you used them. And you can quickly delete them from here as well. Okay, so async stack traces, one of my favorite features of IntelliJ IDEA debugger. In the modern world of async calculations, well, Max told something about this today. There are some situations where you appear in a async task calculation. So here it's a really, really simple program. Don't kind of think about it. It just runs something asynchronously. Then it runs something asynchronously again, and then you stop inside that task. So if you stop there in the debugger, and for now I disabled the async stack traces, but they are enabled by default. So if you disable that, you will only see in the stack, you will only see the internals of the kind of completable future and fork join pool and nothing interesting. So if you don't know, this filter button hides all the library calls. So here in the stack, you cannot see who kind of initiated the calculation of async 2 here, who initiated the async 1 here. There's no main here. So what's happening in the program? You cannot get this. And to solve this, we introduce async stack traces. So it is enabled by default. So you will, in your kind of applications, immediately see this stack. So it goes inside the completable future, and then it switches to the async stack trace. And then you have here the call that initiated this async task. And then if you go further, you will have the call that initiated this async 1 task. And this way, it's really, really easy to track how your kind of data and your program flows through the async calculations. We have hard-coded presets for this, for kind of standard JDK executors, for Swing, for JavaFX, for some other things. We may add some more if you need this, but some people have custom executors in their applications. So they asked us, how do we use this functionality with our custom executors? And we have a solution for you now. So this, once again, really, really simple and trivial example of custom executor. It has a new kind of thread, dedicated thread, which does in an endless loop processing of a queue. And schedule method adds a new task to the queue, and the task is kind of just an integer object. So really, really simple and trivial scheduler for your application. And if you stop in the process method here in the debugger, you will see nothing interesting, just the internals of this thread. So you cannot get from the stack to the kind of schedule method. So who scheduled this task? We don't know. So to solve this and to enable async stack traces with your custom kind of scheduler, we have a special annotation inside the JetBrains annotation package. And it's a simple package available in Maven, Gradle, whatever. And it has several useful annotations you can add into your code to make it kind of, to make IntelliJ IDEA work better with it. So in this particular case, we have two annotations, async schedule and async execute. Async schedule you need to use in your kind of schedule method, and process you need to use in your execute method, the method which kind of executes the task from the queue. And you need to annotate either the kind of the object which is used as a key inside with this kind of mapping schedule with process. So you add these annotations, you start your application in the debug mode, and you'll see what we have. So now it has added the async stack trace automatically. And from here, so you can see that the process was for the kind of the first task. And from here, from the stack trace, we can quickly go to the exact schedule invocation with the first task, and if we resume, we can go to the schedule of the second task and so on. So this way, it's really, really easy to make it work with your custom schedulers inside your code base. But there's more. So some people approached us and told us that they don't want to use JetBrains annotations. Well, we asked why, and they told us just because. So you can use your own annotations, actually. So here in settings, you can go to async stack traces, configure annotations, and you can specify your own annotations. So you need to add one annotation for schedule, one for execute, write it down here, and async stack traces will work for your code base even without the need to have a dependency on JetBrains annotations. All for you. So we have like 10 minutes left, and I will tell you one more thing. So everybody knows about renderers in the IntelliJ IDEA Java debugger. So when you have an object in the debugger, you can modify the toString presentation of the object, which is shown right here. So I don't have it here, so nothing is shown here. And also you can change the presentation inside the kind of the tree. So the fields, you can replace them or add new or do something else. So here, actually, I have a linked list, and I called it fast linked list just because, well, if you call something fast, people think it's more kind of fast. So it has a value and next and a link to the next node here. So of course, when you see such object in the debugger, by default, it does not extend any kind of JDK collections interfaces. So by default, it will be really, really tricky to get the size of this collection and to get all the elements from this collection. So as you know, you can go to the view as create and create a new renderer for this. And here you can substitute the size. So the toString presentation, you can add the toString, you can add the size calculation here, and you can add the kind of the children calculation here. But this way, it will not be shareable with your colleagues, for example. So we have another way to do this, and this is once again a Java annotation. Oh, JetBrains annotation. So we have a debug render annotation, and you add it to your code base, and you specify the text you want the debugger to show instead of the toString, and you specify the expression to use instead of the children of the node. So here we have a simple two-array implementation for this fast linked list. And we use it in the size as well. So of course, it's not that kind of efficient. We can write more kind of better implementation of size here. But anyway, so if you add this annotation to your code base and you kind of put it into the repository, and other developers take it and debug it in the IntelliJ IDEA debugger, they will, without kind of any further setup, get this nice presentation of this collection. So they will have the size here, and they will have the elements here. And this is kind of extremely kind of powerful technique. We have some custom collections inside the IntelliJ IDEA code base, and we added some renderers like this to the code base. And now kind of everybody see this as it should be. So this is a collection. So it should be rendered as a collection. So this is how it works right now. We just added that there and forget it. So it has the size and elements. So how do you switch back to the original presentation? Everybody knows, like view as object, and you will have your old presentation. Well, not for the sub-object, but still. So with all of this, thank you for your attention. Debug more and use debugger not only as a debug tool, but as a tool for the application development. Thank you very much. And I think, Helen, we can switch to questions.
Yeah, thank you very much, Igor. I certainly learned a lot from that, and just reading the chat on YouTube, so did a lot of our viewers. There was a lot of love for the stream debugger that you demonstrated specifically. comments such as "It's quite cool," "Mind blowing." There was a question that I believe was answered in the chat, but just to reiterate, were there any debugger features that you demonstrated today that are not available in our community edition?
No, this actually is a released version 2020.3.2. So you can try to use it right now. And I think we will share this, well, I can't say slides, this class so that you can play with it.
Fantastic. That is an excellent segue, actually. I'm going to jump around the questions a little bit. We have 2021.1, which I'm still struggling to say, is our next release. Are you willing to be drawn on any debugger features going into that release or future releases?
I wanted to say yes. We kind of trying to implement different approaches actually to the user interface. So as you've seen, we've tried, I've shown just a little of the debug tool window because with the years, now it's really kind of has a lot of labels, a lot of buttons everywhere. And in modern world, people tend to use more lightweight interfaces. So we play a lot with the user interface of the debugger. I will not commit that it will be in 21.1. Yeah, but we plan to do a lot in this area.
Good to know, thank you. So another question that again was answered in the chat, but I will ask if you've got anything to add to it. The question was, I cannot modify final field values when I'm debugging. What is the problem to implement that? I.e., will that be possible someday? And the response from a member of the team in the chat, we believe it is a limitation with the JVM debugging API, prohibits changing those values. Is that something that you're familiar with, or do you want to add anything to that?
Yeah, that is a limitation. Yeah.
Okay.
For some situations, we probably may kind of to do this, but I probably don't want to go to that right now.
Okay, fair enough. Thank you. Okay, so another segue. What would be, in your opinion, the best way for a new user to familiarize themselves with the debugger in IntelliJ IDEA? It's obviously a very rich tool, a very powerful tool, but if you've not used it before, can you give some tips for getting started with it in that instance?
Mm-hmm. Okay, so we actually added a lot of new information to the documentation of the IntelliJ IDEA, so you can start from there. There are a bunch of good tutorials actually right now available there. They have different kind of situations where they show how to use debugger more effectively. Also, we plan kind of a series of videos about debugger, and actually we have them at the moment, so you can go to tips and tricks about the IntelliJ IDEA debugger. We have these videos available. So start from there, I think, documentation videos, and start using that. Actually, you can just go through menus. There are a lot of different things there. People tend to use only line debug, line breakpoints, and that's it. But there's much more in the IntelliJ IDEA debugger.
I think you've really opened our eyes to that today, just the huge range of tools that are there to support us, which is fantastic. What is the, I'm going to really put you on the spot here. What is the top feature of the debugger that you can't live without? And I'm going to try and make you just pick one. We'll see how that goes. Okay, two is your maximum.
Okay, you'll be surprised. So I'm a mouse user, as I have said already. So I like to use mouse a lot. I have a kind of physical mouse. So if you can see it here,
yes.
And so it has like the back forward buttons, which are really useful when you go through the code. And also I set find usages on the middle mouse button so that I could quickly navigate with control click to the declaration and with middle mouse button to go kind of back to the usages of the methods. Because of that, I really can't think about living without AltClick Evaluation, which I've shown today, because I use it a lot. So I think it's much more useful, because you look at the variable, you want to see its value. And I use AltClick a lot. And so this feature is the first in my list. And if you want 2 features, I would say memory view. So
Okay.
I was one of the developers implementing this, and now I believe this is a kind of the real window to the information about your application. Because without it, you only see what you have in the context of the breakpoint which you are currently stopped at. And with memory view, you can see kind of everything inside your application.
Fantastic, thank you. Okay, Igor, that was incredible. There's been, well, there still is a lot of love for that presentation on YouTube. Everybody learned a lot, so thank you for writing it. Thank you for taking your time to be here today. It was really very valuable. So yeah, thank you very much.
Thank you, Helen, and thank you everyone for joining me today.